This is a course on Introduction to Materials. Basically, we will be talking about nature and properties of materials. In this part, the part 1, we will be looking at structure of materials. By structure, I mean basically the atomic structure and the crystal structure of materials. This is a 20 hours course, which means you will have 40 half-an-hour lectures, and this is a course basically which requires a background which could be BSc in physics or chemistry, or it could be bachelor's in non-materials related discipline. It's even useful for master's students in non-materials background, for example in masters in engineering, masters in mechanical engineering, chemical engineering, or masters in physics. So basically it is suitable for all the students who have not had a dedicated course on materials, looking at the structure and properties of materials. Now let me talk about the contents of the course. In this course, since it is about structure of materials, we will be mainly looking at the structural aspects. So we will start with the basic crystallography, its introduction, what is the role of what kind of crystal systems we have, what kind of crystal lattices we have, what is the role of symmetry in determining the crystal structure and crystal systems. We will also introduce you to Miller indices and interstices in the structures, so that one can correlate various properties later on with various axes in the unit cells, because a lot of properties, as we know, they have anisotropy in them. And then once we have obtained this basic background on crystallography and crystal systems and Bravais lattices, we will move on to structure of materials. So first in this sequence we will talk about structure of metals and alloys, whose formation rules are different as compared to other materials. So in this case we will mainly look at, for example, Humereau 3 rules and how the metals form various structures and their alloys. And then we will move on to structure of ceramic materials, because structure of ceramic materials is formed by a completely different set of rules, because ceramics contain two different kinds of ions. They contain anions and cations. As a result, electrostatistics plays a important role in determination of these structures. So we look at structures of ceramic materials such as sodium chloride, magnesium oxide, calcium fluoride, etc., and the materials which are based on those structures. And then we will look at another class of materials, that is structure of polymers. Now polymers and perhaps glasses, these are different classes of materials in the sense that they tend to be they don't tend to be completely crystalline. As a result, the structure of these materials is slightly different, is quite different actually, and one needs to know about what kind of structures these materials make, and what is the distinction between polymers and other materials. Once we have known about the structure of various classes of materials, we will move on to structure determination. How do you determine the structure, for example, crystal structure of metals, alloys, or ceramics? And we learn about X-ray diffraction in that context. The basics of X-ray diffraction, its application to determination of crystal structure, and things like crystallite size, strain, etc. And finally, materials are not without the defects. We look at the defects in materials, primarily looking at the point defects and line defects and surface defects, which are useful to know once you have had some background in the crystallographic structure of the materials. So this will be end of 20 lecture series or 40 lecture series or 20-hour lecture series in nature and properties of materials, looking at the structure of materials. Subsequently in part 2, as and when it is conducted, we learn about the thermodynamics, phase equilibria, phase transformations, and properties of materials subsequently. So this is the summary of this particular module, that is structure of materials and introduction to materials, nature and properties. Okay. Thank you.